Hi there, the Math Dog here. So in this video I'm going to look at the area and perimeter of a triangle. I would classify this as a grade 6, maybe 5, 6, 7th grade topic. You could move all the way up to 8th grade Algebra 1, and I guess you could review it for geometry if you wanted to. So before tackling this video, you should have watched my video on the area and perimeter of parallelograms, because that's going to be essential to understand what I'm doing here. This video is not to be shared or reproduced without the written consent of the creator. That's myself, the Math Dog. So, starting out, what do you get when you rotate one to two identical triangles and fit the triangles together? So, I'm going to do a little demonstration here. So, these are identical triangles in shape and size, so they're congruent. And I'm going to try to place one right next to the other, like so. That's pretty good. So you notice what you get here is a parallelogram. These opposite sides are parallel. This one and this one, this one and this one. And then let's just do another triangle and show that the same thing. So I'm rotating one and moving it. I'm translating it so it's on top of the other. And again, I get a parallelogram. As we know, the area of a parallelogram from previous work, the area of a parallelogram equals the base times the height. Okay, so let's just take this one. So the height is also called the altitude. Altitudes intersect, so it's like a rope here. I've used that analogy before. So if I drop a rope here, this is the height of this parallelogram, or the altitude, call that h. The height, which is like from the ceiling to the floor. Then this here, that's my base, B, I'll call it B for base. There, and we showed before that if you like cut this triangle here and paste it over here, you have a rectangle, and the area of a rectangle is base times height. So the area of a parallelogram, is also base times height. So now let's look at triangles and parallelograms. So here I have a parallelogram. I could call it ABCD, parallelogram ABCD. You could also call it parallelogram ADCB. You could start at B, call it parallelogram BCDA. You just have to go all the way around the parallelogram and naming these vertices in a correct order. Now you can start at any vertex and you can go either counterclockwise or clockwise. So the height of this parallelogram is right here. Calling that the height. That's an altitude. If we drop a rope, it intersects the bottom here, this base, at a right angle. This is the length of the base. Recall again, the area of parallelogram is base times height. Notice that triangle 1 is congruent to triangle 2. Congruent means same shape and size. So the area of parallelogram is, since these are two congruent triangles, triangle 1 is congruent to triangle 2. We can write that as triangle 1 is congruent to triangle 2. I spelled it out here, but this should be a little squiggle. Let me do that again. So the sign, the symbol for congruent, which means same shape and size, is like equal sign with a little squiggle, tilde on top of it. We call that a tilde. Tilde, T-I-L-D-E. So that means congruent. So since these two are the same, I could call this actually, well, this is triangle 2, but I could call it triangle 1 really too, because it's the same shape and size as triangle 1. So the area of parallelogram is 2 times the area of triangle 1, or 2 times the area of triangle 2. Okay, another way then of saying that is, so if I got two area, so let's call area A, let's use A for area, so I don't have to write all this out. So let's take a look at this one. So this is A equals 2 times, I'm just going to abbreviate this, area triangle 1. I don't know, let's figure out how we're going to do it. So we use different, so we don't get things mixed up here. I'm going to let T equal the area of the triangle, P equals the area of the parallelogram. So just rewriting this, P is 2T. Well, that means if I'm solving for the area of triangle, I'm dividing by 2. So T equals 1/2 P. So the area of triangle 1 is 1/2 the area of the parallelogram, and I'm just going to draw a little parallelogram there so I don't have to write that out. And also the area of triangle 2 is 1/2 the area of the parallelogram. Okay? Well, the area of a parallelogram is base times height. So the area of a triangle is going to have to be 1/2 base times height, and that's what we're trying to get at here. So in general, the area of a triangle is 1/2 the area of a parallelogram, but the area of a parallelogram is base times height. So using this illustration here, the area of a triangle is going to be 1/2 BH, based on how I labeled this triangle. 1/2 B times H. Okay, then the perimeter of the triangle is going to be the distance around it, which could be, you could go A plus B plus C, because perimeter is simply how far it is around the triangle. So if you had to walk around this triangle, if you started here, it'd be there's the length of A, there's the length B, there's the length C. All right, now a triangle can have 3 types of altitudes, or that's what I'm going to say here. So the altitude, or the height, this could be measured on the inside of the triangle in the case of this problem. It's right in here. On a right triangle, it's one of the sides here, because this is a right angle and this is a perpendicular. Remember, I didn't say this in this video, but again, the altitude intersects the base at a right angle. And when you have two line segments intersect at a right angle, we say they are perpendicular. Perpendicular. And the symbol for perpendicular is that. So an upside down T. So in a right triangle, the altitude right here is actually one of the sides, because it intersects the ground. We could consider this the ground, intersects the ground at a right angle. Okay, then finally, in some triangles, this obtuse triangle here, where this is an obtuse angle, the way I've positioned this triangle, the height is actually outside the triangle. I forgot to put the right angle there, but this is the height, and then this is the base. Again, the formula is 1/2 base times height. So it's always going to be 1/2 base times height, but the height could be inside the triangle. It could be in a right triangle, it's going to be one of the sides, it's going to be the vertical side. And then in a obtuse triangle like this one, the way I positioned it, the height is actually outside the actual triangle. Alright, so now let's do some problems. So got some decimals here, but that's good practice. We need to practice that. So the area of a triangle is 1/2 base times height. So in our particular triangle, it's going to be 1/2 times, in this triangle, there's your height right here. So that's going to be 1.18, and the base is going to be 5.30 meters. So that's 1/2 of 5.3 times 1.18. I think the easiest thing to do here is take half of 5.3. Well, half of 5.3 is the same as dividing 2 into 5.30. Move your decimal point straight up. 2 goes into 5 twice. 2 times 2 is 4. Bring down the, subtract, get the 1 there, bring down the 3. 2 goes into 13 6 times. 2 times 6 is 12. Subtract, that's a 1, bring down the 0. 2 goes into 10 5 times. So it's 2.65 times 1.18. So we got a little bit of a multiplication here. Hopefully we have some room. I may have to do it down here. So let's do it down here in the next problem. 2.65 times 1.18. That's going to be a 3 by 3. There's going to be 9 total multiplications. Ignore the decimal points for now till the end. So we have 5 times 8 is 40. Carry the 4. 6 times 8 is 48. Plus 4 is 52. Carry the 5. 2 times 8 is 16. Plus 5 is 21. So that's the first one. Now I'm going to add a placeholder 0 here. So when now I'm going to multiply everything by 1 here. So 5 times 1 is 5. 6 times 1 is 6. 2 times 1 is 2. Now I'm going to multiply everything by this other one, but I need to add 2 placeholders because I'm now taking 5 times 1, which is 5, which goes right there. 6 times 1 is 6. 2 times 1 is 2. So now I'm going to add these all up. So I get 0, 7, 1, 6, and 5 is 12. Carry the 1. 1 plus 2 plus 2 is 5 plus 6 is 11. Carry the 1. So I get that. So I now move the decimal point 1, 2, 3, 4 places to the left. 1, 2, 3, 4. So my area is 3.127. So I'm just going to round this to, talk about rounding, I'm going to round it to the hundredths digit because that's the most accurate measurement I have. So that's a 2 there. That's what I want to round to, but it's a 7 behind it, so that is going to move that up. And remember, if you're rounding the digits 5, 6, 7, 8, 9, you round up. 0, 1, 2, 3, 4 stays the same. So this is going to be about 3.13. And the units are meters on all the dimensions. So this is going to be meters squared. Okay. So now the perimeter, we've got to add this. This isn't part, well actually that's not the perimeter. The perimeter is this, this, and this. Let's outline that. So the perimeter is here, here, and here. Now when I multiply, I line the digits up on the right, but when I add, I line up the decimal points. So that's 7.92, 2.80, 5.30. So that's 2. 9 and 8 is 17 and 3 is 20. Carry the 2. 2 and 7 is 9. 2 and 5 is 7. 9 plus 7 is 16. Move the decimal point in, so that's 16.02 for the perimeter, and that's going to be meters. So 16.02 meters, and the area was 3.13 square meters. Okay, next example. Here the height is 3.3, the base is 20, this is inches, so the area is going to be square inches, so the area is 1/2 base times height, which is 20 times 3.3. But half of 20 is 10, so we have 10 times 3.3. Okay, you could just, it's going to be 33 times 10, this is going to be 330, move decimal point one place, that's going to be 33, but if you want to, let's do the multiplication. 10 by 3.3, that's 0, 0 times 3 is 0, 1 times 3 is 3, add a placeholder 0, it's hard, that's not very well written there. I'm sorry, 0 times 3 is 0, 1 times 3 is 3, placeholder 0 right here, 0 times 3 is 0, 1 times 3 is 3, we get 3, 3, 0, move decimal point one place to the left, we get 33. So the area is, we'll call it 33 square inches. Then the perimeter is the distance around the thing, so that's going to be 6.3 plus 13.4 plus 20. So we got 6.3, 13.4. Remember, I'm lining up the decimal points when I add. And then 20. Well, 20 actually is 20 point. That's a whole number. The decimal point separates the whole number parts from the fractional parts. So the 20 goes right here. Let's add a decimal point and a 0. That's how you add here with decimals. So now 3 is 4 and 0 is 7. Bring down your decimal point. 6, 3, and 0 is 9. 1 and 2 is 3. So that's 39.7 inches is the perimeter. Okay, so those are two examples for you. Now I want you to do these two practice questions. So stop the video. And stop the video, do problem 1, then I'll go over it, then you can do problem 2. So we'll just do problem 1 here first. Alright, so let's do the perimeter here on this one first. You could have done the area, but the perimeter is going to be adding up the sides. This is a right triangle, so my height is actually, which I don't need to know that for perimeter here, but that's the height, 3.6. So I got 3.6 feet, 4.8 feet, and 6. I'm going to put a decimal point there, like so. So that's 14, carry a 1. 1 and 3 is 4. 4 and 6 is 10, so that's 14. Bring the decimal point down. That's 14.4 feet. Then the area is going to be 1/2 base, which I'll call 4.8. You could have used 3.6 actually here too. That's 4.8 times 3.6. Well, half of 4.8, half of 48 is 24, so this is going to be 2.4. Then I'm going to multiply 2.4 by 3.6, and I should get my answer. So I have 2.4 times 3.6. Ignore the decimal points for now. 4 times 6 is 24. Carry the 2. 2 times 6 is 12, plus 2 is 14. Add a placeholder 0 here. Now 4 by 3. 4 times 3 is 12. Carry the 1. 2 times 3 is 6, plus 1 is 7. So now add them up. That's 4, 6, 8. Move decimal point 2 places to the left. That's 8.64 square feet. Okay, the area is 8.64 square feet. The perimeter is 14.4 feet. Question 2. Okay, there's my height now. That height's outside the triangle. That's my height. My base is here, 15.8. Notice if you extend the base, again, you have a altitude, and these intersect. These are perpendicular. Here, they intersect at a right angle. So the area, I'll do the area this time first. And by the way, I'm going to stop the video for a second, let you work on that. So this is my base, this is my height. Alright, I'm going to do the area first on this one. So the area is 1/2 the base, which is 15.8, times 7.91. I'm going to do half of 15.8. So 2 goes into 15.8. 2 goes into, and bring the decimal point straight up because it's just a whole number here. That's 2 point. 2 goes into 15 7 times. 7 times 2 is 14. Subtract, you get 18. 2 goes into 18 9 times. 9 times 2 is 18. So we get 7.9. So this is 7.9 times 7.91. So I like to, when I have multiplication with different number of digits, I like to put the one with the most digits on top. You can do it another way, but I think this is a lot easier. So I have this. Notice when I multiply, I line up the right, I don't line up the decimal points, I line up the right digits. So I'm just going to treat this like 791 times 7.9 here for now. 1 times 9 is 9. 9 times 9 is 81. Carry the 8. 7 times 9 is 63. Plus 8 is 71. Now add a placeholder 0 here. 1 times 7 is 7. 9 times 7 is 63. Carry to 6. 7 times 7 is 49. 49 and 6 is 55. So now add it up. And notice this is a 3 by 2, so you have a total of 6 multiplications that we did. 1, 2, 3, 4, 5, 6. So that's going to be 9, 8, 4, 12, carry a 1 there, 6. So I have 3 places behind decimal point, 1, 2, 3. So I go 1, 2, 3. So I get 62.489. 62 point, let's write that again. Excuse me. 62.489. That's going to be miles here squared because the units are miles on the linear. Now, that's the area. Now the perimeter is going to be 25. Put a decimal point after that. 25 miles plus 7.91 miles. Now I'm going to add a 0 there, so that's 7.91. Notice when I add, I line up decimal points, and I'm going to add another 0 there as just a placeholder. Then I have plus 15.8. So when I add, I line up my decimal points. Okay, I don't want that there yet. I just want it should be plus 15.8. So I've got 15.8, and I could add zeros here. I could add zeros here just to make sure everything lines up. There's my decimal point. It's going to go right here. So 0, 1, and 0 adds up to 1. 9 and 8 is 17. Carry a 1. 1, 5 plus 1 plus 5 plus 7 is 13. 13 plus 5 is 18. Carry a 1. 1 plus 2 plus 1 is 4. So we get 48. The perimeter, just call it P here, is 48.71 miles. And this concludes the video.